here we see the program, and I have used GitHub Copilot. It is fun time to generate code with these AI tools, only if we know what we want. So here is what the program I asked to generate. GitHub Copilot created a basic structure of the program, and you push it to the editor. Here is in the middle. Right hand side is the chat that I'm doing with the AI tool, the GitHub Copilot, and here it is. And it also has given us the uh, detail of the program with the comment, header file included, stdio.h, and the main. All the C, C++, Java, and Python program starts when you execute, it starts with the main. The operating system looks for the main where it is, and that's a starting point. In C, the main looks like this. It returns either a 0 or 1 or any other number, 0 meaning success, and it takes some parameter. And parameter can be void or some arguments. We will talk about the arguments later. We dive into that's advanced concept. Here, printf is a function. It will print on the screen. And that printf function is defined in stdio.h file. And then we return 0, just a success. And if we execute that program, you will see hello world. And in this case, we have a new line. So it will generate a new line after printing. So if we go execute quickly, just see that. And we are in going to C folder. And we can do C. We run CC, C compiler, and test dot C, and output file is a test. So that's where it will generate. And it compiled. If we see, this is the today's timestamp, May 28, just now, 8 a.m., 8:12 a.m. So if we run test, we run like this, dot slash executable. This is executable. So here is the hello world. So this is a simple structure of the program. Now we will build on this what we want to learn. So we have some prompt created. I have some prompt created beforehand. We will go through that. And I am just telling the GitHub Copilot, the AI tool, that this is the coding structure I'm looking for with clean modular code in C, and you, meaning the AI tool, as you are a senior C programming expert, meaning you need to give a persona to the AI tool that what it should be. If you say psychologist, it will act as a psychologist. Like that's the role you ask the AI to play. In this case, senior C programming expert. And we just say this, and after that, we will ask for data type. Okay, so what it did is because I have a context, the C file, so it modified to do certain things. You can have it in the editor and compile and execute, or you can you can ignore it. So here is what some documentation also it gave. Why did it do this? So here is what we did in the prompt. I asked it in the problem that you will do a modular code. Earlier one wasn't that, it was a simple code here. And I have asked to change it to make it more performance, portable, maintainability, all the quality, debug and logging statement, those were not there, error handling, meaningful comments, and inline documentation, all that I asked to do that. So it did, and I have the file that's called context. This file is test file. Add context, you can add another file like this. So in this case, what it did, it modified that file, and it also has given few more commenting style, like author's name, your name you can put, today's date. And it did the error handling I asked, so it did some error handling code from stdlib and error number. So here is what it did. Here is the main. So this, on the editor, the main is simple. Here is a little bit more. Debug program started. So that will be in the debug print. And we have put in a pointer in a constant pointer, hello world. And then it did print greetings is a function it wrote here, print greeting. And then it did std out and the greeting string. And in this one, this print greeting, you can, because we have modularized, so it std out, so the file type is std out, so it will print there, printf. Or if you want this text to be printed in a file, so you can actually give a file name here, and that string, the greeting string, will be written to that file. So it's more modular, and you can easily modify this and make it printed to the file instead of the output std out. But here it just did std out. Also, it has if it doesn't print, then it exits. It said, okay, fail to print the greetings, printf, and exit failure. If not, program completed successfully, then exit success. So this exit success and exit failure are in stdlib. So those are, success is 0, failure is 1 in this case. Any non-zero is failure. And here is what a macro it defined, the debug print. We see the debug print. What is it? It's again a printf to the std error out, and type the string, the log type is debug, and your formatted string. And if it is debug is defined, then it does. Otherwise, it will just do nothing. So this is how, suppose you are executing this code in testing and you enable debug, you define in the before this if defined, if def, and then you can print. Otherwise, it will print nothing. The second option. So it's more modular. Here are some descriptions. And error handling is done. Error number, p error. Where is p error? It did p error here. If it couldn't print this, it will be less than 0 byte, meaning if printed nothing, failure to print, and this p error is a function which is coming in error number .h, and so that's what it was explaining. Error handling is done. modular structure is done, debugging support is done, modern practices like constant string and exit success failure, and then you have the doxes and style, this one. So your file name, brief, and here is the parameter and return type, the function description, and here is the main function description. So that's what it's taking. It's portable, available in all platforms. And here are more C programming best practices. These are descriptions that what C programming you can have in C programming. So modular, how it is modular, documentation. You can read this later, pause the video, or find the document that I will share, and the memory management, portability, all these best practices are taken care. And here is the how to execute, how to compile, and then here is the debug we're talking about. You can pass in the compilation time. So this debug is this debug here, if it is defined. In compilation time, if you give -d and that debug, it can be info or certain things. So that is taken within the program as a defined, so -d. And here is the output if you run like this. So we can take this code on the left hand side, it will change, and if we push this and this file is changed, so we can undo this. I wanted to show something else, so we'll undo that, and then we will come back and take this code. So we are inserting some Git knowledge here. It's helpful. See, we have created two test files. One is test.c, another is test.cpp files. So two are two different folders. CPP is C++. And in the C folder, we have test.c, and we can add this to the Git, or we can actually add here Git. And so when you do Git status, it shows what are the untracked files. We have nothing we tracked yet. And by the way, before this, we had to do a Git init. I did that. And now I can say Git add C test.c. I can do that, or I could do from here the plus sign using the, here is the file, this is the Git symbol is there, source control, and if you go there it will show the changes, and we can see undo or plus, or it will copy to open the file. It is not copy, open to the editor. So let's do it here. It's easy. The button stays the changes. And then same thing we'll do with CPP. Now it says a staged file, and launch JSON and task JSON. Let's do that as well. And now all of these files are added. So if we do git status now on the command prompt, so all the file it says committed, to be committed, and or you can restore using this command git restore. So also look, these files are in green color. Previously these folders were, or files were in red color. So now if we commit, we can say commit, or we can actually git commit /m is a message, what you want to write. And we can say initial main test file, initial test files for C and C++ programs. And also another way is you can write message here on the screen here on the editor. Same comment you can put and then hit commit command. So I'll do this from the command prompt. So same, we need to know all command prompt as well as the VS Code, the user interface. So if we do this, so now all files are committed. And if we do a git status now, so there is nothing to be committed and all clean tree. So all these files are now within Git. Now Git knows that these files are tracked. And if we change anything, these files, that changes will show up. So this is what I wanted to show, that now if we take this change, the new change to the main is created. So then it will be, if we do this one, this button apply to C test file, and now it is changing, and the file is changed, and the red color, which is removed, and the green is added. If we keep now, the file is now modified with the new changes. If we save, and now if we do git status, git status, so now this is a file that said modified. Also, you will see here that one file is modified. Here is the difference it will show. And if we see that, the difference is, compare these two files. The left-hand side is the old code and the new file, new changes on the right-hand side in the green, and the old changes, old code was in the red. So this is how we compare using git diff, and so that you know what changes you made, or any other team members, they made any changes. So if we close this and if try to execute, go to C folder, and let's do compile again. What are the files we have? There's two. And this time we will cc we have here. If we do cc, now test file will be generated. Do test. So the hello world printed with the new hello world in this code, this one, main here. What about this debug? If we do a debug, and if we compile with debug and debug, so now it should be, it is created a new test file. You see the timestamp, yes or no? No, it did not change. Or it did. Okay, let's do it again. Yeah, so timestamp changed, 8:30, 8:29, it was before. Now, if we do a test run, so you see the debug program completed successfully. That's what it is, the debug print. So I hope this helps. And when you are compiling, this is what you enable, that debug. Here it is, debug. Yeah, so main debug, Yeah, here. So if def. So this one will be taken, debug. If def debug, so that's how it is taken. So this is how a program you will start with and then keep modifying and use Git in order to keep track of the changes you made. One more thing here that I asked the AI tool to create or update a markdown file. So that's why it created this, and we can take this to a markdown file, .md file, so readme.md in the C folder. So I can push this to the editor. It is then asking whether to create a new file. Yes, it's a new file in the C folder. And then we keep it. So this is the file we will maintain in order to document all the work that we are doing, README file. And now we will enhance this program or create new to understand the new concept in C program. And we are diving into data types, variables, and constants. So here is a prompt I have written, and we are talking about write code describing data types, variables, and constants. And this is how we write the prompt, and as much detail as it should be concise, not too much repeated text, but what we want exactly, that's what we're asking it to do. And then I hit enter. It should create a new file with describing data types, variables, and constants. So there you go. See data types, variable, and constants. Program is written. File name data type underscore demo. And we'll talk about this program in detail. Let's see what it generated. It did three functions: demonstrate data type, constants, and type conversion. And it followed the same structure as the previous code we had, is logging mechanism, and then the documentation and different data types it mentioned. Here is the printf it did, and demonstrate constants, this function, and then demonstrate type conversion. And this is how you will run the program. There is sample, and it did not update the markdown file. That's fine. So what we do, we can take this code. It generated in less than a minute. And we just needed few effort, a little bit of effort to write the prompt, a few minutes maybe, based on the knowledge we have. And now let's take this to the editor. This is the chat, and we take this to editor. It's asking me to write in a new file, data underscore types underscore demo in the C folder. Yes, it did. Take to the editor, and we keep it. We can undo, we can keep. So now we save the file, and here is what we have. So this is a new file. So without any change or understanding, I'll just execute this code and see what it does. And we do cc underscore cc. We don't have debug here, so we say data underscore types output data type. Say or we just say DTD data types demo DTD. Okay, this is the output file, and then compiling. It compiled. And then we run using dot/dtd, that executable it created. And here you go. All the output that the printf statement in the code has been used. So here, basic data type, integer, and floating point, character, Boolean, and the constants here, and then type conversion. So let's go through the code and the output. So we have on the top, then we have, the main program as we discussed previously, and it has three functions. The main program, it says printf program name. That's the program name. Yeah, data type demo. This is the text. It's a macro. So there is a data type demo. It will print here. And then this function will be called, then this function, then the third one. So what is here? Data types. So it says section data type here. And then there is a line printed. And there are some integer data type, short, long, and long, and unsigned int, and unsigned character, floating point data, temperature, and double precise value with the like 3.14, and is a pi value, and a character type A, and a character new line. And there is a Boolean, and these values are being printed. Let's see what it did. So integer type, here it is, integer type, and we have int. The value of regular int is 42. It assigned 42 here. And then we have size of int. Size of int is says size 4 byte, and this is how you say GU percentage. This is the int value, this is the size, 4 bytes, and range from this to that. What is the range? And min and max. What is the min? Is min here? Oh, that's taking from the header files. I think that's the limits. So, and you can see, yeah, limits. So this is the file here. This is the file from the library. So limit is printed from this value to that. So it's a 32 bits, 4 bytes data. So this from, it's not unsigned, it is signed. So it is minus to plus this number. Same thing for short, value is printed. And if short is 2 bytes, and the range is from minus this to that. Long is 8 bytes, size is 8 bytes. And long size is still 8 bytes. And Unsigned int. Unsigned int is not, there is no negative value, so it will be max value of this. 4 bytes, that means 32 bits all are calculated as value. And in signed case, the most significant bit is considered as the sign. Like if it is 1, it is negative. If it is 0, then it is positive. Same thing, unsigned int, unsigned character is 1 byte. And floating point, float, this is the value we saw here, temperature, 9860. How is it printed? Floating point here. It's a dot 2, like 2 precision. And size float is also 4 bytes, and double is 8 bytes. And the precisions are 15 digits, and in this float, 7 digits. Characters, 1 byte. Here is a character printed. ASCII value is 65 for A. The character is A grade. And new line, special character. And that is your /n. ASCII value is 10, 10. And these are the data types. And then comes constants. You can have constants defined. Pi is a constant. Where is a pi defined here? Here. So it's a defined macro. And max students, all these are macro. So they are printed as constants. And here are the values. And you can also have constant variables. Defined macros are here, and these are variables, meaning these are in memory. These are constant values, so they don't change. And these values are printed here. There they are. And then enumerated values, that's like enum. So for weeks, months, all these you can put in enumerated. And enumerated values are whatever value you give the first one, or you can provide individual values. Or if we just put the first one, the subsequent values will be taken for the subsequent enumerated types. And these are the values. These are printed here. Today, Wednesday says, and so days of the week. And where is the value printed here? These are right here. So today's Wednesday says, and that's why it's printed the value here, 3. This value, 3. And same thing, you can have colors. Those colors are printed here. Blue is 5, red is 0, green is 1, and you see here the numbers changed because we started with, again, we can assign value like this. We can now, it doesn't have to be sequential. So 5, and yellow, we could assign something else. Because we didn't assign, so it will take next value after the previous one, that is 6. And so conversions, we can convert certain values. And if a smaller value, like a 2-byte value converted to 4 bytes, you don't lose data. But if you have 4-byte data, int is converted to short, you will lose 2 bytes of data there. So these conversions are here. And let's see what it did. Yeah, here. So character A is converted to ASCII value int. So like this you will do in C, within parentheses, that which type. The letter A is now converted to ASCII, the int value. So they are printed letter and ASCII. You will see here. Letter A, 65, and the ASCII value, where it is. Character ASCII value. There. Yeah, this is the one. So the character A, and we can convert double into int, so that will truncate the value. So it will only have 3 in this case. So rounded pi is printed, it should be a 3. So here double is this and int value is 3. So this is how we, if your target, your destination is smaller in byte, then it will be losing some data. Int doesn't have your decimal values, so it will truncate that. So this is how we do conversion from one data type to another. Here are a few more examples. Int, and it is here, it is dividing, but it is putting into the integer type. So it is losing the decimal part after decimal point. So here it is 2. Decimals truncated. But if it is double, you convert it to double or floating point, then it takes the correct value. 5 divided by 2 is 2.5. And it is also casting that first number to this. So this is how we use the data types, variables, constants, macros, and constants and conversions. So this is the foundation knowledge for all programming language, and C is the mother of all modern high-level programming language.